Welcome back to another M&S tutoring video where we're going to be learning today about the different trigonomic ratios with right triangles. Well, what are trigonomic ratios? Well, these ratios are the ratios between the three sides of a right angle, and the ratios will be the same for two similar triangles. So there's three trigonomic ratios in each right angle triangle that correspond each one of its sides together. So let's take a look at the right angle triangle and basically what happens when you're contributing to the different sides of the triangle using the different trigonomic ratios. So here we have right angle triangle A, B, and C, right? And angle C is the right angle, and everyone knows that the side opposite to the right angle is the hypotenuse. So I'm going to label it hypotenuse. The angle, the opposite of the hypotenuse is, of course, the opposite side, right? And this is known as the adjacent. Now, something that many of you didn't know is that any side that is a reference angle inside the right angle triangle is known as theta. And theta is drawn by a little a little diagram that kind of looks like that. And the hypotenuse, as most of us know, is the biggest side of a right angle triangle. And the adjacent is found next to the theta angle, and the opposite is found opposite of the theta angle, right? Just like that. And then the adjacent is adjacent, and the hypotenuse is across from the right angle. So now let's look at the different ratios with a triangle. So the first ratio that exists within a right angle triangle is opposite, so the opposite side over the hypotenuse, right? The next ratio that exists is the adjacent side over the hypotenuse. And the last ratio that exists is the opposite side over the adjacent, right? And all three of these ratios have a relation, and we'll get to that really soon, have a relation to sin, cos, and tan, which are the three different trigonomic ratios involved with a right angle triangle. So in similar triangles, as I mentioned before, all three of the ratios will be similar, as the two similar triangles have proportional sides. So you have to make sure that the hypotenuse, opposite, and the adjacent side are in reference to the right angle and theta. And say, for example, you had a triangle like this, and you had theta up over here, and you had the right angle over here, right? This would still be the hypotenuse, right? But in this case, this would be adjacent. This would be opposite because it's opposite from the theta angle, and this would be adjacent. So you have to reference all of your sides based on the theta angle and the right angle as well. So now let's look at sin, cos, tan itself right now. So a good way to remember which ratio corresponds to what is using SOHCAHTOA. SOHCAHTOA is an easy way to remember whether sin is applied for opposite over hypotenuse, whether cos is applied for adjacent over hypotenuse, and whether tan is applied for opposite over adjacent. So you have to remember SOH, S-O-H, CAH, C-A-H, TOA, right? What this really shows is that sin is for S, and then O and H shows opposite over hypotenuse, right? And it's the same thing moving on. It's cos is equal to adjacent over hypotenuse, and tan is opposite over adjacent. So SOHCAHTOA is just a really good way for you to remember all these trigonomic ratios. After you guys start using these ratios, it'll just kind of all be in your head. But at the start, this is a good way to remember which trigonomic ratio corresponds to which one. So how do we actually use these trigonomic ratios? Well, say for example, you have right angle triangle, another triangle here. And I'm not going to label it right now because it's too much work. But say for example, you have this triangle and you don't know this side, but you do know this side and this side. Sorry, this angle. You know this angle over here. right? Now, believe it or not, actually, I'm going to label it just so it makes it easier when I'm explaining this to you. So, say now that you know angle A and you know side B and C, believe it or not, only knowing that this triangle is a right angle triangle and side BC is 5 and angle A is 30 degrees, you can find out how long side AB is. Well, this might seem like a shock to you, but it's actually really self-explanatory if you use the trigonomic ratios. So remember when I mentioned that so is sine opposite over hypotenuse? Well, if you look at this, the two different angles you have are 5 and x, and 5 is the opposite side of this triangle and x is the hypotenuse, right? So right now if we do sine 30 it's not sine 30 is equal to opposite over hypotenuse. Well, in this case, opposite is 5 and hypotenuse is an unknown, it's a variable. But since it's the only variable in this equation, we can solve for it. And we simply get sine 30 is equal to opposite, which is 5 over x. And if you plug in sine 30 into your calculator, you'll get 0.5 is equal to 5 over x. And this simplified is x is equal to 5 over 0.5, which gets you an answer of x is equal to 10. And you have actually solved for side AB, and now you know that instead of x, side AB is 10, right? So that's just a quick insight of how you can use trigonomic ratios. It's really, really basic, but it's actually how you can use trigonomic ratios to solve for the different sides, and quite possibly now we're going to be looking into how you can solve for an angle in a triangle. So let's look at this example over here, and say you have triangle A, B, and C right over here, side A, B, and C, right? And you want to find this angle over here. But all you know is that this is a right angle, and you know that side AB is 10, it's labeled centimeters in this case, and side BC is 5 centimeters, right? Right now we're given the opposite side because it's in reference to theta, you got to remember that, and we are given the hypotenuse, right? So now we can use sine again to help find theta. So you can set up your equation saying sine theta, because we don't know what it is equal to 5 over 10, right? And you can get sine theta, so you can simplify it even further. You can get sine theta is equal to 0.5, and now you have to bring sine to the other side. Well, what operation is sine in with the theta angle? Well, it's not really an operation. If you want to bring sine towards the 0.5 side, you have to inverse 0.5. So it's sine inverse, sine negative 1, 0.5. And if you punch that into your calculator, you should get theta is equal to 30 degrees. Well, if you don't get theta is equal to 30 degrees, make sure that your calculator is in degrees and not radians, because you might get another answer depending on whichever mode it is set to. So that's the end of the video, guys. I hope you learned something new about how you can solve different sides and angles of a triangle using the sin, cos, and tan ratios. Remember, in this video, I only showed the sine ratio over here, but if you have the adjacent and the hypotenuse, you could for sure use the cos ratio, and depending on your case, you could use the tan ratio as well. You just have to remember the SOHCAHTOA definition that I showed you, and you'll be all set to go when looking at trigonomic ratios. Other than that, if you have any comments or concerns, please feel free to leave it down in the comment section below, and I'll get back to you as soon as possible. Other than that, thanks for watching, guys.